Hi everybody, it is Tuesday and here we are with your day 6 homework. At this point, from this point forward, you need to put your inspires away and take everything we've learned and the connections we've made and apply it to different situations. So today we're going to go through some other parent graphs we've seen before, not the four basic, most common ones, but 2 to the x, 1 over x, and even the log base 10x, although that will continue to be an optional thing. But anyway, we're going to take some different parent graphs and we're going to apply the same transformation rules to them. You should be on day 6 homework in your homework packet, which isn't really homework, it's guided notes to guide you through these lessons. I'm going to skip number 2 and do that last, and probably as a second little could or should do video, and we're going to focus on 1, 3, and 4. And that will be it. It should be pretty short and sweet. So starting with number 1, if I zoom in, we are asked to graph y equals 2 to the x plus 1. Now, our parent graph here would be y equals 2 to the x. And that was one of our last 3 parent graphs that we talked about last week. A reminder, I'm not going to make a table, but you could, and without an inspire it might not be a bad idea, but I'm just going to think about the numbers in my head. So if x is 0, 2 to the 0 is 1, so I plot the point 0, 1. When x is 1, 2 to the first is 2, so I'm plotting 1, 2. When x is 2, 2 squared is 4, so I'm plotting 2, 4. When x is 3, 2 to the third is 8, and I'm plotting 3, 8. Now, we said that the anchor point for a 2 to the x graph is this point 0, 1. So I'll label that so we can see the transformations from there. And don't forget some fractions. If x is negative 1, 2 to the negative 1 is 1/2. If x is negative 2, 2 to the negative 2 is 1/4, and so on. And this is where we saw our first asymptote. In this case, it's the x-axis. It is the line that this 2 to the x graph is approaching but never touching. Okay, so there's our parent. Now, the child graph is 2 to the x plus 1. You want to think of an exponent as a grouping symbol. So we could rewrite that as our child as 2 to the x plus 1. And it's not a bad idea to rewrite using parentheses so that you can remember our math is consistent, and anything within parentheses or any grouping symbols means a left-right translation, and because it's a plus 1, it actually means move everything left 1 unit. So I'm going to take all these points on my parent graph and move them left 1 unit for my child graph. And we will be set. Okay, like I said before, we're going to skip 2 for now, and let's move to number 3. So here I have y equals negative 2 times 1 over x. Our parent graph is y equals 1 over x. That was our hyperbola with 2 different curves and 2 different asymptotes. Again, think about numbers when I take your inspires away. So 2 to the first, 1 over 1, if x is 1, 1 over 1 is 1. 1 over 2 is 1/2, 1 over 3 is 1/3, 1 over 1/2 is 2. Remember, we call this the reciprocal function. 1/3 is 3. So there's the first part of my hyperbola, and then we can plug in negative numbers as well. 1 over negative 1 is negative 1, 1 over negative 2 is negative 1/2, 1 over negative 1/2 is negative 2, and there's some key parts to that parent graph. Again, this is called a hyperbola. The x and y axes are both asymptotes. They're both lines that this graph is approaching but never touching. Okay, well with the child, I'm doing 2 things. I'm actually negating it, which reflects over the x-axis, so we'll do that first. We'll reflect over the x-axis. So you take all those points and go the same distance on the opposite side. There's my first child. These points go the same distance on the opposite side. It's the second child. And this is where you really might want to get some colored pencils, because when we get more than one transformation, it's hard to keep them all straight. Then we'll take that reflected hyperbola and we will dilate it by 2. So we're going to vertically stretch it by 2. We're going to take the distances from the x-axis and multiply them by 2. So if I take this distance from x, which is 1, and multiply it by 2, it stretches way up here. When I take this distance from the x-axis, which is 1.5, it looks like, no, -2, sorry, stretches way up here to 4. When I take -2 1/2, this 1/2 distance, 1/2 times 2 stretches up to 1. So there's that side of my hyperbola, and we do the same thing here. 1 times 2 is 2. 2 times 2 is 4. 1/2 times 2 is 1. And there's your final child. And they get a little messy, and again, that's why we'll suggest some colored pencils as we go along. Okay, the last notes graph, number 4, for this part of the video. We're back to our parent, 2 to the x. And again, this entire exponent's in parentheses, so we always do parentheses first with PEMDAS. X minus 3 in parentheses, we'll take it right 3 units. And this minus 3 at the end means we'll take that last graph down 3 units. So we'll start with our parents, 2 to the x. 2 to the 0 is 1, 2 to the first is 2, 2 squared is 4, 2 cubed is 8. 2 to the -1 is 1/2, 2 to the -2 is 1/4. And there's our parent, 2 to the x, with its anchor point of 0, 1. Now, we're going to move that graph right 3 units. 1, 2, 3. 1, 2, 3. 1, 2, 3. And then we're going to take the most current graph and move it down 3 units for our final child. Now what's really interesting with these graphs that have asymptotes is the asymptote also moves up and down if necessary, or right and left when necessary. In this case, my asymptote is this line on my parent graph. It moves to the right 3, but you can't see that because it's the same line, but it also moves down 3. So with these graphs, you also need to label and plot your new asymptote. We tend to graph asymptotes with broken lines, and we label them with their equation. So the equation of the x-axis is actually y equals 0. When that moves down 3, it becomes y equals -3. And then our final parent curve approaches that new asymptote but never touches it. And notice I missed that point by accident, and that's okay, as long as I can see it on the parent. And that is it. We'll come back in a bit for the log parent and transformations.